Okay, let's look at problem 5 from the homework assignment 17. In this one, I have a velocity selector, which is inside of a mass spectrometer. And they give you a picture of it in the problem, and also there's pictures of it in the textbook. And I tell you that it uses a 0.12 Tesla magnetic field. The question is, what electric field strength is needed to select a speed of 3.70 times 10 to the 6 meters per second? Okay, I draw a picture, trying to draw a picture similar to the one they had for this problem, where the first half of this drawing, I have both an electric field and a magnetic field. The electric field is running in the same direction as the charged particle. And the magnetic field is perpendicular to the motion of the charged particle. The selected speed, or the selected particle, the particle that has this particular speed, has to go through straight. It has to go straight through this opening. In order to do that, I have to adjust the electric field just so that it balances the magnetic field that is pulling the particle downward. So the magnetic field, the force is going to be directed down, so it would bend the particle down, and so it would miss the hole. So I have to balance the electric field so that it keeps the particle straight. So the force of the electric and the force of the magnetic field must be equal to get this particle to move straight. Okay. Once I go through the opening, the only force acting on the charged particle is in the magnetic field, so the particle is then allowed to bend in a circular motion, and it has a particular radius. They give me the magnetic field, which is 0.120 Tesla, and they tell me how fast the particular particle needs to be, which is 3.70 times 10 to the 6. So the question is, what is the electric field? Remember, electric field is represented by the symbol E. The concept that I'm going to use is going to be the force on a charged particle due to the electric field, and it's going to be the force on a moving charged particle due to a magnetic field. So we're going to use these two concepts to solve this problem. The relationship for the force on a charged particle due to electric field is going to be F is equal to Q times E. This is the electric force. And the force on a charged particle, on a moving charged particle due to a magnetic field, will be F of B is equal to QV sine theta B, where theta is the angle between the velocity and the magnetic field. So what is known is the magnetic field and how fast the particle is moving. What is unknown is the electric field, which is what I'm looking for. So the plan is, again, these two forces must be equal in order for the charged particle to move in a straight line. If not, if the magnetic field is too large, it will bend in one direction. If the electric field is too large, it bends in the opposite direction. So you want it to go straight, so the two forces must be equal. So I know these forces, I know what they're equal to. The electric force is equal to Q times E. The magnetic force is equal to QV sine theta B. So I can set these two equal to each other and solve for E. Once I do that, I get the charge cancels out, which is fine because they did not give me the charge of the particle. So what I get is the electric field is equal to the velocity of the particle Sine theta, theta being the angle between the velocity in the magnetic field and the magnetic field. I know that sine theta is equal to 1 because the velocity in the previous picture, is perpendicular to the magnetic field. So that gives me a theta, gives me a sine theta of 1. So E, the electric field, is going to be equal to the velocity times the magnetic field. Now I know the velocity and I know the magnetic field, so I can now solve this equation. So executing my plan, I can now plug in my values for V and B. And I get an answer of 4.44 times 10 to the 5th volts per meter for my electric field. Okay, so this was part A to problem 5. So now we'll look at part B. Part B, the question is, what is the voltage between the plate if they're separated by 1 centimeter? So the question is, what is the voltage? Remember, voltage is going to be delta V. And the concept I'm going to use is potential difference. The relationship I'm going to use is potential difference is equal to E times D. D being the distance, separation distance of these two plates. This relationship was not covered in either our reading or in class. So I understand if he was unable to find this relationship. But it is delta V is equal to E times D. So what is known is the distance and the electric field, because I just solved it in the previous problem. What's unknown is delta V, the potential difference. So use the relationship delta V is equal to E times D. I know the electric field, I know the distance of separation. So then I can execute the plan by plugging my numbers into this relationship. And I get an answer of 4.44 times 10 to the 3 volts. In this particular problem, WebAssign wants the answer in kilovolts. So my answer is going to be 4.44 kilovolts because kilo is 10 to the 3rd.